In this tutorial, we're going to look at exception handling in Lambdas and how you need to catch exceptions in Lambda. Most of the things that we're going to be talking is obvious, but I'm going to talk about a strategy that you can use to handle exceptions in some of your Lambda expressions. So I'm going to create a new class here, and I'm going to call this exception handling example, and this is going to have a main method. Now what I want to do is create a Lambda here which takes in an array of integers and a key which is an integer, and do a mathematical operation for each element in that array given a key. Let me explain. So let's say I have an integer array. Let's say some numbers, and I'm going to initialize it to a bunch of numbers. What I'm also going to have is a key. Let's call it 2. Now what I want to do is do a process method. I need to write this process method which takes in some numbers, just this array. It also takes in a key, and then I want to write a Lambda expression here which is basically the expression that I want to apply this key to for each of these numbers. So I want this process method to loop through these numbers, and for each of those numbers I want to apply the key. What is that application? It is this Lambda expression. I want whatever is this Lambda expression to be performed with each of the numbers here and the key. Now let's say I want to add the key to each of these numbers and print that to the console. Let me get rid of this thing here and create the static method first. I'm going to loop through this list of this array of some numbers. So I'll say for, let's say I want to print each element added to the key, right? So I'll say system let's say I plus key. Now the output of this should be fairly obvious. It's just going to print the addition of those individual numbers with the key itself. But this is what I want to convert to a Lambda expression. I don't want this process method to do just one thing. I want it to be able to process any mathematical operation that I pass into it. So what I'm going to do is I'm going to pass a Lambda. So the Lambda will be something that takes in 2 arguments, 2 integers, and it doesn't do anything. So we've already seen that there is an interface called byConsumer. So let's say I take byConsumer as an argument which takes in 2 integers. I need to use the box type for integer because we need to do that for generics in Java. I'm going to say consumer here, and let me import byConsumer. Now what I want to do is apply the consumer, which is the Lambda that's passed in, over here. .accept, which takes in 2 arguments. The first one is the element in the array. The second one is the key. So now I can pass in the Lambda which does that print. So what would the Lambda be? It's something that takes in 2 arguments, which is the value and the key. And what it does is system.out.println value plus key. Now let's run this and make sure the same thing is returned. Now I can change this behavior to, let's say, a slash, and I'm doing a divide. So if I were to run this, I'm going to get an integer division. Now let's introduce a scenario where there is an exception. Now what if, let's say the key is 0. Now what's going to happen? I'm going to get an exception, an arithmetic exception, divide by 0. Now how do I catch this exception? And where do I catch this exception? I guess the how is simple. You just need to do a try-catch block like we've been doing in Java for a long time. Now where do you catch the exception? One very obvious answer is you catch the exception over here when you're doing a consumer.accept, right? Now this is taking in a consumer, which is an operation. Now this operation is what's failing, right? When I'm doing a consumer.accept, I'm executing the operation, the Lambda that's passed in, and that's throwing an exception because I'm doing a divide by 0 here. So I could do this. I could say try here and then put this inside a try, and then I do a catch, and what I'm doing is arithmetic exception E, and then now here I can do whatever I want here, handle the exception. But now arithmetic exception is happening because what we are doing here is this v/k. But you don't know what's the input that's going to get passed in. This might be a completely different operation, and arithmetic exception doesn't even apply. Maybe there is some other exception, maybe another runtime exception or a null pointer exception that you need to handle. So does that mean that this is going to have a long list of catch blocks? That doesn't seem right, because the process method doesn't really know what this operation is. So this exception that you're catching is very specific to that operation. So it's obvious that you don't want to handle that over here. We want whoever is passing in that lambda to handle that operation. So here's another thing we could do. I'm going to remove this try. We want this to be fairly light, right? We don't want this process block to be worrying about what exception could be handled and then handling all those exceptions that could be passed in over here. It's not the right way to handle that responsibility. We could say, well, the lambda could handle that exception. So if I were to add a try catch over here, that would mean it's no longer a single line. I need to have a braces here. So let me move this inside the braces. Here, what I'm going to do is I'm going to have a try. And let's say I'm going to have a system.out.println. An exception happened, or let me say an arithmetic exception happened. All right, we are swallowing the exception here so that there is really nothing printed on the console. For example, this should do, but you can handle it in a different way over here. Now if I were to execute this, you can see that it's printing out the message and it's not showing the stack trace, which is good. But now look at our lambda. It was so neat and small and easy to read. Now this is a mess. I have a try catch over here and it doesn't look as elegant as it did before. So this is also not a good idea.